Hi guys, so we are starting with your CS2 15 chapter. This is the first chapter. Okay, in this lecture, how are we going to proceed? What I am going to taught, what is expected to you? I will just give you a brief idea about it. Okay, so basically in your Google Drive folder, I have uploaded our programming files. Okay, so the files are as per the structured format of your CS2 chapter wise. So you have to view your introduction file. So what is the introduction file? You just need to go through it. Okay, these are introduction based on what you have studied in basically your chap CS1R. Okay, and apart from that, basic understanding of a chapter 10, 11, 1. Okay, how to import the data, how to export the data, plus minus basic understanding of your. So first thing first, you need to revise these two things. Okay, once you're familiar with it, you have to go to loss distribution, that is chapter 15. So in this chapter, as you can see, this is the structured format. Okay, here, if you see, this is an introduction sheet. So this gives you an idea about what is there in CS1 chapter 15. There is an exponential distribution, gamma, log normal, Pareto, Burr, everything is given here in a structured format. Okay. Basically, I will be teaching you these course notes. Okay. These two files I will be teaching you. So today's first lecture, I will be teaching you this file. With then when you have studied this file, okay, once you have viewed the lecture, you have practiced what I have done. Okay. Then you first have to visit this file again. Okay. This is like a proper structured format of what I'm going to teach you. Okay. You need to go through it properly. Okay, based on that, there are additional questions for you to solve. And then with respect to those questions, these are the solutions. If you see the solutions are directly in the form of your basically, see, directly the code is written as well as the answer. So you do not have to wind about it, इधर है, क्या है, वैसे. And if you want to view the R files are also here. Apart from that, the data files are here. Yes, everything is structured in this way only. Okay. So first thing first, let's start with chapter 15 first course notes. Okay. So starting with the first section, this one. Okay. Since you have studied in your CS1 chapter 1 would be an extreme base for you in order to proceed with CS2. Okay, so chapter 1 mein you must have studied D binom, B poise, B norm. Okay, it is just going to be the repetition. Apart from that, we'll learn something new. So for exponential distribution is DEXP. For calculating the PDF. For calculating the CDF, it has to be PEXP. Okay. Lambda is a parameter, and what would be your x would be the number which you want the distribution of. Q is probability x is less than equal to q, so less than equal to q is this. P is basically QEXP is basically in order to you, if you have the CDF value, if you want the right value, it would be this value. Okay, and REXP is to generate the number. Similarly with gamma, log normal, and variable. Don't worry, we will solve a few sums, then you'll get an idea. Okay, first thing first, you need to remember this table. Okay, याद रख लो कैसे है. Okay, what would be the first input value, second input value. Second is always your, if you see the parameter, यहाँ पे भी second and third are your parameters. Okay, variable में देखो third parameter is something different. It is c raised to -1 by gamma, so you need to remember this. So first thing first, remember this table before we move on to solving your sum. I expect you all to be like a bit quick with respect to this now. Since you have been doing CS1, you have done CS1R, therefore I really expect you all to know these basic functions, okay? So let's start with it. Let's start with your R model programming. So my first question, I want to calculate the PDF of your value 30, given that it follows exponential parameter with the parameter of lambda as 0.005. Sorry. Yeah, 0.05. So how do you calculate the PDF? DEXP. Okay, you want with respect to 30. So 30. And what is your parameter? 0.05. So basically our answer is 0.011155651. Okay. If you want the log likelihood, okay, log likelihood, then this formula would be exactly same thing. There would be just one difference. That is nothing but your log is equal to true. Okay. This is how you calculate log likelihood. Okay. This would be new to you. So understand this. Okay. Now this was with respect to your one variable. Okay, this whole thing was with respect to a one variable. Let's go on to two variable case. Two variable in multiple variable case. Multiple variable case. Okay. So basically your x has certain values of x. Okay, so let me write that vector. It would be 18.9. Okay. I'm just writing a random number. Okay, this is basically given in your notebook only. So notebook, sorry, PDF. So this is given in your PDF. So I'm using that one only. I'm not generating anything of my own. Okay. Okay. First thing first. Do you remember हम लोग के steps जो होते हैं 7 chapter CS1? Do you remember the step? Okay. हम लोग है ना हमेशा product of your PDF लेते हैं. So how do you calculate the product of your PDF? So DEXP मैं लिखूंगा. Okay. My first parameter would be this x value. Okay. And my parameter with 0.05, which is same. You see, you will get some multiple numbers. हमेशा हमारा जो PDF होता है that is with respect to your CS1 chapter 7. Okay, we always use products of fxi. Okay, you can even see in your OneNote thing. Wait, let me show it to you. CS2 chapter 15. 18. No, I cannot see it here. Okay, let me see if it is saved somewhere else. Maybe in my book. Nope. I hope this would be here. Let's see. ये तो MGF हम लोग ने वो सब देखा था. No. I don't know where it is right now. But ठीक है, you can open your notebook and check it out now. So that would be basically your product of your FXI. तुम लोग को FX तो मिल गया for each individual value, but you do not have the product. So what do? I save this as some variable. Suppose L save किया है. So I will just use product of your L. Okay, the short form is PROD. Write just L. Okay, L not found. Wait, now see. So basically, this you got your nothing but your product of your FXI. Sorry, FX with respect to each variable I. Yeah. Or I could write it this also FXI. Okay, anyways. So you got your product, but suppose मेरे को log likelihood चाहिए. Log likelihood. So log likelihood basically would be nothing but your log of your product of your L, which is basically log इसका log, simple form में. So your log L is basically minus 40.95232. Okay, you could do it in some other way also. So this is method 2 I'm teaching you in order to find the log likelihood. Okay. So first things first, you will copy paste this DEXP. Okay. Now इसका है ना मैं यहाँ पे log is equal to true डाल दूंगा as done in the first case. सीधा log likelihood के लिए. But if you see, I have several different values. I will just add those values. Okay. I will just add those values in order to get the defined narrative. If you see 40.9532, 40.9532. I just taught you two methods how to calculate the log likelihood. Okay. Oh yeah. This is basically okay. थोड़ा और examples देखते हैं. Okay. You learned how to solve the log likelihood now. Let's view a few examples. You need to calculate PDF of your value 50. Given that it follows gamma distribution with parameters 6 and 0.1. Okay. So how do you calculate? I'll just write x is equal to 50 here. And I will use this formula. Okay. D gamma. So D gamma x comma alpha comma lambda. Okay. Now if you want the PDF, sorry, this is you got your PDF. Now if you want capital CDF, okay, capital F50 CDF चाहिए, then you will copy paste the same code. So only difference is here it would be your P gamma. Okay. So now suppose you have your PDF, okay, as equal to 0.98, but you do not know the X value. How do you do? The again same thing. Copy paste करता हूँ मैं. Okay. So this would be a Q gamma. Instead of X, it is 0.98. So you got your answer as 120. So fx of 120.2698 is basically 0.980. Similarly, if you want to produce several values, then R gamma. How many values? I want to produce 100 values from alpha as 6 and lambda as 0.1. So yeah, you produced your 100 values now. Same you can do it for, okay, same thing. You can do it for normal distribution. Okay, what is it? DL norm, sorry, D norm, P norm. Same thing, okay. P norm followed by Q norm, R norm. Same thing, okay. Instead of this would be mu, and this would be nothing but sigma, not sigma square. Okay. The same thing would be for a basically log normal also. The only difference in the code is it is DL norm indicates this as log normal and only N indicates normal. So it would be PL norm, QL norm, RL norm. Suppose let's do one question, okay? You want to find F of 1000, PDF of your 1000, okay? For a log normal distribution which has the parameter of mu as 5 and sigma square, okay, as 4. So तुम लोग क्या लिखोगे? It would be DL norm, okay, of your 1000 of 5, and this would be square root of your 4. Okay. So basically now your answer would be this. That is what it is important. Okay. Let me do one more question also for you. Okay. एक वेबुल वाला देख लेते हैं. वेबुल, understand, वेबुल ऐसा है. So एक वेबुल वाला भी देख लेते हैं. Okay. I need you to produce 20 values of a Weibull distribution with the following parameters as P is equal to 0.12342. Now gamma is equal to 4 and वेट सी यू हैव गामा या बस यही दो पैरामीटर होते हैं. सो आर वेबुल आर वेबुल ओके आर वेबुल 20 वैल्यूज बराबर 20 वैल्यूज ही प्रोड्यूस करना था ना. लेट्स जस्ट चेक 20 वैल्यूज gamma 4 है तो 4 I will write here and the formula is c raised to minus 1 by gamma. So c would be 0.12342 raised to minus 1 by gamma. So minus 1 by gamma. Now, oopsie. Okay, यहाँ पे bracket close हो गया इसलिए. Yeah. Oh, oopsie. Raised to minus 1 by 4. हाँ हो गया. See, if you want a fixed answer as mine, so use any set dot seed. Okay, set dot seed suppose मैं 25 use करता हूँ. So but you must get this answer only what I'm getting. Cool, this is how you do. See guys, I'm not wasting your time too much because I know that you all already know this. Okay, so I really want you all to visit these parts. So यहाँ पे सब कुछ लिखा हुआ है. We did it till here. Now basically this is a new question. You have this thing. Okay, now this is basically to find d ये log likelihood find करना है. So log likelihood is nothing but d variable और उसका sum तो वही किया है. And then they have done the following things. Okay, so quantile कैसे use करने का सब कुछ यहाँ पे detailed है. So this is what you need to do. I expect you all to at least know this thing because this is basically your common sense or your whatever you have done in your CS1. So this is not something new you are learning. Just खाली नया distribution आया तो कैसे parameter सीख लिया तो फिर मतलब there is nothing else to learn, right? So you just learn log likelihood and variable distribution कैसे करने का. That's it. मतलब you haven't learned so much. So I expect you all to know this thing due to CS1. So what I want you all to do is basically यहाँ पे हर एक sum क्या है ना हर एक sum understand the question. ये रहा code solution. I want you all to solve it in an R sheet. हमेशा ऐसा format रखोगे. 15.1 okay would be a chapter. Then I want to solve your answer. Questions के हिसाब से solve करने का. As I told you, these are the questions. Wait, I'm showing you again now. तो हमेशा वही solve करने का. You have to solve this. पहले ये कोर्स नोट्स प्रॉपर लिखने का. अंडरस्टैंड इट, लर्न ईच एंड एवरी कोर्स. टेक दिस एज योर एग्जाम. एग्जाम में एक चैप्टर पढ़ा और उसके रिस्पेक्ट तुम लोग ने सम किया विदाउट सीइंग द सॉल्यूशन. एंड में सॉल्यूशन चेक करो, मार्क योर मिस्टेक, राइट इट इन अ पेन. सिमिलरली यू विल डू फॉर 15.2 एज वेल, बट 15.1 पे अभी रुकते हैं. ओके, आई वांट यू ऑल टू टेक द प्रिंट आउट. किसका किसका प्रिंट आउट लोगे? Okay, you will take the printout of an introduction, summary and all the question sheets. ठीक है, ये प्रिंट आउट क्यों लोगे? we'll do that later, but whatever your mistake is with respect to your basically questions यहाँ पे just write it there in a red pen. Okay, compulsory in a red pen. Okay, and I want you all to send me those red pen वाला mistakes also. So that would be easier for me to go through what your mistake is and appropriately मैं तुम लोग को extra sums और वो सब भी दे पाऊँ उसके लिए mainly. Okay, and send that to me whenever we'll have doubt solving of a chapter 15 hours. तब मेरे को बोल देना कि we'll go through it. Okay, apart from that, ये क्यों चाहिए मेरे को summary sheet, summary and introduction sheet. You do not have to view it right now. Okay, if you really want to pass my exam, please listen to my words. ये चीज खुला मत रखना. Don't keep this open. Keep ये print out निकालो इसका and just keep it somewhere in your cupboard. Okay, You have to remove these sheets, okay, when you are doing your revision or basically when you are appearing for your exam. So अभी इसका मतलब कोई नहीं है, but I want you all to keep the printout and just keep it ऊपर कहीं पे safe. You do not have to be, okay guys. If you do not follow my words, I'm not liable that if you pass. सीधा मैं मुंह पे बोल रहा हूँ, अगर तुम लोग मेरे फुटस्टेप्स पे नहीं चलोगे, मैं 100% बोल रहा हूँ तुम लोग फेल ही होने वाला हो. लिसन व्हाट आई डू, ओके, जो भी मैं बोलूँ, ओके, यहाँ पे ये लर्न करना है, देन गो टू दिस, ये सॉल्व करो, राइट योर मिस्टेक्स, एवरीथिंग व्हाट एवर आई टेल यू, यू हैव टू डू इट, ओके, इन दोज मैनर ओनली. नाउ ओके, मूविंग ऑन टू द नेक्स्ट पार्ट. हाँ, now we will study Pareto and Burr distribution. Burr distribution. Okay. So with respect to a Pareto and Burr distribution, I want your formula book to be out. Okay, you have to remove your formula book. Why do you have to remove your formula book? It is because there is no defined function for a Pareto or a Burr distribution. मतलब if you see यहाँ पे हमेशा एक defined function था. You just had to put the parameter. Now here you will understand how to make a new function for your Pareto as well as a Burr distribution. So I want you all to remove your basically क्या था यार, tables book, sorry, tables book. Keep it open. Okay, मैं भी यहाँ पे निकाल रहा हूँ. Yeah, actual formula and tables. Okay, we'll use this tables book in order to define a function. Okay, so ठीक है, let's go to your Pareto distribution first. Pareto search कर लेता हूँ. It will directly land me to the Pareto distribution. Okay, this is a Pareto and a Burr distribution we will be doing. Okay, so Pareto distribution for a 2-parameter thing. Okay, so let's move on to it. D Pareto. D Pareto क्या होता है? D Pareto is nothing but your PDF. So basically you have to write this thing in a coding format. Okay, so how do you write it in a coding format? First you define a function. Suppose D Pareto. Okay, D Pareto is nothing but a function. Function is basically you're making a function. So what all are the parameters you need for a D Pareto? It is X, alpha and lambda. Okay, then I will open a curly bracket here and here you will write your formula. So this would be nothing but alpha multiplied by lambda raised to alpha, okay, divided by bracket 1 plus x, the whole raised to alpha plus 1. Okay, this becomes your D Pareto function. You can even use this as a D Pareto function. मतलब same ही लिखा है मैंने. I have not done anything else. Okay, तो बस मैंने वही लिखा है. It is not 1, यहाँ पे it is lambda L. But this becomes your D Pareto function. Now you write D Pareto. Suppose you want to find for 50, given your alpha is 10 and your lambda is 5. बस मिल गया तुम लोग का आंसर अपना. It's always that way. Similar thing you will do for D Burr also. अभी P Pareto. P Pareto is nothing but your PDF. ये चीज लिखा हुआ है in your P Pareto. I want you all to make a function. Compare your function with respect to your P Pareto as well as your P Burr also. तो ये हम लोग ने देख लिया. Now with respect to your Q Pareto. Q Pareto कैसे करने का? Okay, what you will do? You will write your CDF as equal to some value P. ठीक है? Q तुम लोग एक साइड रखोगे, बाकी सब दूसरी साइड. That's it. Simple instruction. So if you solve it algebra, you get Q as this equation, and that same thing is written in your Q Burr. Q Pareto, Q Burr, sorry, Q Pareto, same thing has been written. So you got your basic understanding how to make your Q Pareto as well. So what I want you all to do for now, ये रहा तुम लोग के पास code, okay? You do not have to apply anything, okay? You do not have to even use your brain here, okay? You can use the help of this code, but I want you all to verify this code, okay? So ये जो code है ना, I want you all to verify this code. R Pareto, you won't be able to basically verify it. So ये तो याद ही रख लो ऐसा ही है. You do not have to apply your brains here. D Pareto you can verify, P Pareto you can verify, Q Pareto you can verify, R Burr you can't. Same D Burr, P Burr and Q Burr you can verify, right? So basically remember, verify it, okay? Try kar lo khud and see that formula comes out as expected. And this is a set of codes which you already have. You do not have to apply your brain, okay? So अगर एग्जाम में कुछ आया, okay, of with respect to a Pareto distribution, Burr distribution, you will keep this page open, not exactly this page, okay? This is also written in your summary page. जो मैंने बोला था कि ऊपर रख दो, introduction page जो मैंने बोला ऊपर रख दो, that you can use it in your exam. But as a practice matter, I want you all to basically solve it on your own. मतलब जैसे मैंने लॉजिक तुम लोग को सिखाया ना, वैसे ही तुम लोग खुद ट्राई करो and do it. For R Pareto and Burr, basically you can use the formula. That's completely right. But for these three, I want you all to basically try it out on your own. और जो भी वो लोग ने आगे सॉल्व किया है ना, some example see, they have solved, they wanted this answer, so you can try it out now. P Burr run किया and just write all the values. That's it. You should always get these things. So basically that's it. That's important. So matlab you have to try now. This function I just taught you how to deal with it, so you need to deal with it. Let's move on to a few more examples we solve, okay? So we'll solve this sum only as I said earlier, okay? यही sum देखेंगे, okay? This sum only. So a random variable x follows a Burr distribution. You have to make a cumulative distribution. So cumulative distribution क्या होता है? P Burr. Okay, so P Burr का मैं formula define करता हूँ. P Burr is equal to function, okay, Q, A, L and G, four parameters. It is nothing but 1 minus, let me just see the formula, Q Burr 1 minus lambda upon 1 minus lambda, के ब्रैकेट में लिख लेता हूँ lambda divided by lambda plus, ये ब्रैकेट में डाल देता हूँ, x raised to gamma g, okay, to gamma the whole raised to alpha, the whole raised to alpha. You got your P Burr. Now the question is basically you may have to draw a P Burr for 0 to 100. So let's make a sequence. X डाल देता हूँ, x is equal to, say Q डाल देता हूँ because here you have defined Q as your first variable. Oh no, I have defined your x. So your x नहीं Q आना चाहिए because this is what the function is. Okay. So x is equal to sequence. Sorry, I'm defining this as Q. Q is equal to sequence from 1 to 100 with a step of 0. छोटा step लेता हूँ, okay, 0.01 or 0.1, whatever you want to do. That's okay. Let's not make it from 1. They want it from 0, so 0 ही रखते हैं. Okay, now your Q. ठीक है. Now let me calculate P Burr for each and every value of Q. So P Burr, okay, P Burr, your Q alpha, let's see, according to alpha is 10, lambda is 500, alpha is 10, lambda is 500, and your G gamma is 0.5. Okay, तो हो गया, P Burr मिल गया. So why it's coming for a single value? Let me save that this as x, okay? And then let me plot x, sorry, q with respect to x. Sequence from 0 to 100. Hey, why is x coming as a single value, yaar? P bar 1 minus lambda upon lambda plus q, lambda plus q. Wait just a second, give me a moment. Lambda plus q the whole raised to gamma the whole raised to alpha. ठीक है, अपना p bar भी right है. ये हो गया. This is how your graph turned out to be. You can even verify this with respect to your diagram which they have drawn here. Yeah, you have a diagram. Yeah, you could verify this. Now with respect to your 3-parameter Pareto distribution. So your 3-parameter Pareto distribution, the same logic. I want you all to verify the logic. But obviously, where is the answer returned? Okay, I will show you where the answer is. Wait. Yep. Summary sheet. Summary sheet mein you can find your 3-parameter Pareto. See. Okay. You just have to find for D Pareto. Okay. D3 Pareto indicating a 3-parameter Pareto distribution. So you do not have to do with any respect to any other thing. You just have to check it with respect to this. Okay. Once you have checked it with respect to this, okay, I'm going to teach you how to make a basically PDF. Okay, PDF से हम लोग CDF कैसे करते हैं? I'll just teach you that. So first, let me write the 3-parameter Pareto distribution का function. Okay. Oh, यपी किधर गया our formula books. 3-parameter Pareto ये है भाई, इतना अजीब है यार. P3 Pareto is equal to, okay, function of your x, alpha, lambda and k. Okay, so this would be nothing but bracket में लिखता हूँ gamma function. Okay, this gamma function of your alpha plus k, a plus k, okay, multiplied by lambda raised to alpha, okay, multiplied by lambda raised to alpha, multiplied by x raised to x raised to k minus 1. So x raised to k minus 1. ये अपना एक बन गया. Divided by your denominator, which is your gamma of a alpha, multiplied by your gamma of lambda, gamma of k, sorry, and lambda plus x multiplied by lambda plus x, the whole raised to alpha plus k. So yeah, this would be your, but yeah, this D3 Pareto, you got it. Okay. Suppose now the question is find your Pareto distribution of your x is equal to 50, given that your alpha is 10, lambda is 20, and your k is 100. कुछ भी दिया है, so this is just my thinking, okay? So I'm just checking it out. Q is basically x is 50, 10, 20, 100. Man, basically ठीक है, we must have taken a wrong number. ठीक है, example था, just chuck with the example because I'm not sure what the answer should come out to be. Okay, now we have an official question. Alpha 2 है, Your lambda is 4 and your k is 5. Okay. You have to find probability of your Q, that is your PDF, is less than equal to 10. Okay. So how do you find? That's a good question. So if you see, मैं PDF से CDF कैसे convert करूँ? Integration of your PDF is nothing but your CDF. So if you see, see this is greater than 0. So integration from 0 to 10 would be nothing but your PDF. So let's find it. It would be integration of what value of your D3 Pareto. Okay. So D3 Pareto with respect to 0 and the numbers. So that would be 10. Okay, let me just write A क्या है, L क्या है, and this A is equal to 2, L is equal to 4, and K is equal to 5. A is missing. Okay. I guess I may have made some mistake here. I'm not sure. Missing with no default. मैंने ये तो लिखा है. That's okay. मैं क्या करूँगा? I'm just making this now a new function. Since I have the defined values of alpha, lambda, and k, I will just vanish this out. Okay, and खाली x रखूँगा. Yep, see 45.115. क्या हुआ पता है? Why did I remove these three values? Basically, we took the values here, and now यहाँ पे alpha जो भी value होगा, it will automatically take 2. So now this would be a function of your x only. But in order to have a greater function, it's always better to use this. But जब PDF करोगे, then you have to do this. Integration from 0 to 10. That's it. Okay. So with this, we are just winding up for this lecture. Okay. Next lecture, we will meet for another part of your chapter 15. I hope you understand how we went about things. Okay. I know I have been very fast with this thing, but because I expect you all to know these basic things like कैसे एक formula को लिखने का R में, the function parameter. I know you all might know this. Okay, so I went a bit quick giving you a gist idea. So guys, please, first things first, make sure you have done your course notes first. कोर्स नोट प्रॉपर करो, प्रैक्टिस करो, वो लोग के आंसर तुम लोग के आंसर से मैच हो रहे हैं, ट्राई करो. ओके, देन मूव ऑन टू योर क्वेश्चंस एंड देन सॉल्यूशन. ठीक है. सो guys, I will be checking your these things. Okay, R ka code, I want this in this format only. 1 R sheet for a course note, 1 R sheet for a question. और तुम लोग के पेपर में क्वेश्चन में क्या मिस्टेक्स हुआ है, I want you all to see it also. So with this, we'll be done with like this lecture. Let's meet in the next lecture to do further understanding of the chapter 15. Yeah. Thank you guys. Bye bye.